Hey guys, welcome back to the channel. Hope you're doing extremely well. So let's continue our GFG POTD series. As you can see, we have completed 7 days streak. Okay, it's our 8th day today. Let's see what does the problem say. The problem says count more than n by k occurrences. Okay, more than n by k occurrences. Let's see what does the problem say. The problem says given an array ARR of size n and an element k, the task is to find the count of elements in the array that appear more than n by k times. Okay, so very simple, very simple. As you can also see, it is given to be an easy level problem. Okay, so let's see what does it say. It says array n n is the size. Return, what do we have to return? We have to return the number of elements. Return number of elements occurring more than n by k times. Alright. The simplest approach and the easiest approach, that is the most efficient approach here. The approach is use a map, store the count, traverse the map, return answer. What does it say? It says initialize an unordered map to save the time complexity of type int map to int. Okay. Store the count as in mp of ai plus plus. This is happening in a for or while loop. You can try whichever you prefer, for or while, both are same. I usually prefer for. I usually prefer for. Traverse the map using for auto it mp. Then return answer. This has a manipulation if mp of sorry if it dot second, this will return like this. Map stores key value pairs, right? So a value is the count and the keys are element. So if it dot second is greater than n by k, n by k means more than k and more than n by k occurrences. This is a for more than n by k occurrences. Answer plus plus. The loop will return us answer, and we will return answer to the main function. This was all you had to do. Let's code it down real fast. What did we do? We initialized an unordered map. Start a loop for int I equals to 0, I going up till n, I plus plus. Then mp of arri plus. Then what do you have to do? Initialize an answer equals to 0. Then for auto it using an iterator to traverse the map. If it dot second is greater than n by k, ns plus plus. After the for loop, return answer. So guys, here's your answer. Go and enjoy fun. Let me show you the submit also. Sorry for the early excitement. Work fine. And yesterday I promised you a surprise. So the surprise is this one plus 8. So it says if we for every 8th day of completing a streak we will get plus 8 geek bits. So if you are completing 8 days, then that means you are earning 2 gig bits per day, not one. Okay, so that is a big surprise for you. You will have in this way you can get your hoodies or t-shirts or goodies real fast. Okay, at the double speed. Okay, now for the guys who just wanted to get the answer for the today's GFG POTDs can leave, but I would still recommend to see the next approach I'm going to use, because the next approach is the one that appears in most of the OAs and the placement exams. Okay, So now coming to the different approach and a mind-boggling approach. Okay, this approach is known as Moore voting algorithm. Okay, so what do we have to do? We wanted to find the number of elements with occurrence more than n by k times. Okay, let's assume that k is equals to 2. Then you have to measure n by elements which have gone more than n by k, n by 2 times. Now if you see it clearly, it is more than, not more than or equals to. This is different, this is different. Now consider an array of length 1 2 3 4 5 6 7. This, the length of the array is 7. Now for n more than n by 2, it would be 7 by 2 is 3.5. So we want an element which occurs more than or equals to more than 3.5. Now an element cannot occur half time, so it is coming more than or equals to 4. Now you tell me, suppose a is an element that is occurring equals to the 4 times, okay, the minimum number of times to be a part of an answer. A. Now for the second element to be part of n by 2th time, it has to come at least 4 times. But if you see, only 3 indexes are left for it to occur at a position. So it may be the case that only one element can occur more than n by 2 times. If you don't believe me, I have shown you the case for odd length. Let's consider even length. Okay, so because there can be only 2 types of number, odd and even. Odd is been confirmed by you. If we confirm even also, then this statement is fine always. So considering a length of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, for 10, greater than 10 by 2, that is greater than 5. Greater than 5 means greater than or equals to 6. So if a 6, only 4 indices are left with me. That means 4 is less than 6. It cannot come in this category. So the statement is holding true. So this was for n by 2. Okay. Now consider if k was equals to 3. Going for n by 3 now. Okay. Odd length is 7 now. 1, 2, 3, 4, 5, 6, 7. Even length is 6. 1, 2, 3, 4, 5, 6, 7, 8. 8, sorry. Okay. 7 by 3 is 2 point something. That means greater than equals to 3. We want greater than equals to 3. So A. We want one more element. Okay. B. If C is the C can, so that means only maximum 2 elements. Now for 8 by 3 is 2 point something, so greater than equals to 3. A, B, C can only come 2 times. So here also 2 times. So for we observe, easy to observe a pattern. When k was equals to 2, we were able to observe only at most one. This is the at most value of n by k occurrences. Okay. For k equals to 3, 2. That means for k, the answer could be maximum k minus 1. Okay, so the answer is always less than equals to k minus 1. This is the range of the answer. Now, Moore voting algorithm works like this. Okay, considering n by 2 case. N by 2 case consider, I say as count initialized to 1, element is the first element. Let's consider the first element of the array is the element we want to find. Let's take the example given to us in this 3122 1233. 3 1 2 2 1 2 3 3. We want an element occurring more than n by 2 times. The length of the array is 1 2 3 4 5 6 7 8. So we want an element occurring greater than 4 times, that is greater than equals to 5 times. If you observe, no element is occurring greater than 5 times. 3 is occurring 3 times, 2 is occurring 3 times, and 1 is occurring 2 times. No element is occurring greater than or equals to 5 times. So answer should have been 0 in this case. Now, what does the algorithm says? For I equals to 1 till n minus 1, alright. If ELE equals to A of I, then count plus plus. Else, count minus minus. Alright. After the if else, now again one if count equals to 0, then count is equals to 1 and ELE is a ith element. Okay. After that, this algorithm does not end here. Algorithm says after what we have got in the ELE, check if it is occurring more than n by 2 times. For that, count is 0 again. Traverse going to 0 and minus 1. If ELE equals to AI, just do a count plus plus. No else statement is required now. After that, after the for loop, check if count is greater than n by 2, answer equals to 1, else answer equals to 0. Answer equals to 1 because I am returning the number of number of elements occurring more than n by 2 times. Okay, if I have to do answer equals to ELE, this was the element which is occurring more than n by 2 times. All right, let's see the dry run for it. Dry run would be count ELE I 0th, first, second, third, fourth, fifth, sixth, seventh. Count is initially 1, ELE is 3, starting I from 1, then going to 3, going up to 7, 5, 6, 7. Okay. First element is not equal to the element count 0. Okay, element is 3 here. Then element changes to 1, count changes to 1. Okay. Next element is 2, count becomes 0, element was 1 here. Element changes to 2, count changes to 2. Whoa, count changes to 1. Next element is at the third index is 2 only. So count changes to 2, element remains 2. At the fourth index, count changes to 1, element remains 1. Fifth index, count changes to 2, element remains 2. Sixth index, count changes to 1, element remains 2. At seventh, count changes to 0, element remains 2, then changes to 3, this is 1. Now according to the algorithm, we have got 3 as the element which is occurring more than n by 2 times, and 1 is the count. Now discard count. This count does not guarantee anything here. Just then traverse it, find the number of element times 3 is occurring. 3 is occurring 1, 2, 3. So no, answer should be 0. Okay. Now for the case n by 3. I'm not writing the full approach here. I'm just telling you how it would work. N by 3, okay. For that, count 1 equals to 1. ELE 1 equals to A of 0. Count 2 equals to 2. Or count 2 equals to 1. ELE 1 equals to A of ELE 2 equals to A of 0. Alright. What do we have to do? Do the same for count 1 ELE 1, count 2 ELE 2. Okay. And then check for the both of 2 for n by 3. Because we discussed for 3 only 2 are possible. Okay. So for similarly for n by k we would have to do count 1 ELE 1 going up till count k minus 1 ELE k minus 1. So to store these space complexity of k minus 1 2 star of 2 star k minus 1 is required, and time complexity of nk, because we have to traverse the array again k times to check for the count of all these. Okay, so of nk is the time complexity, of 2k minus 1 is the space complexity, which can be written as O of k also. So I guess that this is inefficient. The one written above about using the map is more efficient. Okay, I just told the approach because of the Moore's voting algorithm. Moore's voting algorithm works fine for deterministic number of n by k occurrences. When we know the k for 2, 3, 4, above it no one ask, then it will be n by k only. Okay, so let's end our discussion here. It was wonderful meeting you again. We will continue to struggle, we will continue to hustle, and we will not stop until we meet our FANG placement, and we will keep solving GFG POTDs and keep maintaining a streak. So don't forget to like and subscribe, and also don't forget to hit the bell icon so that I can bring more interesting videos for you. Okay, bye, tata.